This is the xTool Metal Fab, a 1200 watt fiber laser welder that also transforms into a CNC metal cutter, capable of cutting through steel, aluminum, brass, and even titanium, and a lot more than that, all with zero dross. And today I'm testing the Metal Fab on real parts that I designed, checking for cut quality, for speed, for precision, and any software tips and tricks that actually matter. We're going to be making signs, we're making repair parts, shop organizers, and even giant pieces of wall art. And while we're doing it, we're going to discover a few useful Easter eggs along the way. So if you want to start a metal parts business or bring production of those parts back in-house, this is the video for you. So let's dive in. Even though this is a welder and a cutter and a cleaner and you can do those things manually, I think the biggest advantage of the Metal Fab is its ability to cut intricate parts using the CNC. That's where this machine can pay for itself the quickest. So that's going to be the focus of this video. I don't want to waste any time. We're going to jump right in. So to christen this machine, I have a simple sign to make from a sheet of steel. I designed this sign in xTool Studio where there are several stencil fonts which work perfectly with laser cutting in here. This piece of steel looks awful, and I will explain why it looks like this in just a few minutes. The xTool Metal Fab has a really quick system for clamping material down. There's a floating clamp on the left-hand side. We can just bring it over, and then by turning the knob, it tightens the front and the back at the same time to save time and make loading and unloading material really quick. xTool Studio already has a big database of materials to choose from, so I just picked the one that was closest to what I was cutting, and it suggests the correct setup for the best results for that material. In this case, we have a 2mm nozzle. We're going to be using the air compressor in this case. This is the xTool air compressor. There's also an air dryer as well. We'll press this button and it brings the nozzle tip down to the top of the material so the material thickness can be set in relationship to that nozzle. If the sheet happens to be warped, which is pretty common with metal, the Metal Fab can identify those waves automatically and adjust during the cut. This is a fiber laser, the same technology that's used to engrave metals, except for this machine is way more powerful and the laser is a gantry mounted laser, so it can cut up to 2 feet by 2 feet at once. This machine does have a kerf, but it's less than 0.5 millimeters, so it's extremely fine and almost no waste from the kerf cut itself. This is only about a 32nd of an inch thick steel, 0.8 millimeters thick, probably 22 gauge. This part only takes a total of 2 minutes and 10 seconds to cut out. It's a lot faster than I was expecting. So I've been using this piece of steel under my atom stack laser ages ago when I was cutting through MDF. So it's a huge mess. It's about 4 years old. I think at one point I was also using it to weld on. So I just need a quick sand and it should clean it right up. Pretty good for the first cut on this machine. There's no burr on the back side of the part, and if you remove the blank, no burr on the stock either. Very similar results to what you'd see if you ordered parts from Send Cut Send. xTool suggests that you pick up the waste that has dropped down, and I decided to use sand in the bottom of mine rather than water because I thought that water would humidify my shop a little bit too much. But the sand does make it a little bit tough to find some of those smaller pieces. The drawer is on rollers and it does pull out, but I instead just reached down with a magnet to grab the small pieces of steel. This machine needs to be vented outside. That is one of the benefits of the Metal Fab over other options. It's much cleaner and safer because the cutting is contained and it's being vented. It has a 200mm or 7 7/8 inch flexible hose. I don't have a place to vent it from my shop. I have no hole through the wall or through the ceiling, so I decided to design a 3D printed part and vent it below my big shop door. The print itself is pretty big and just fit on my H2C build plate, but I don't want mice to bite their way through any plastic, so I designed a stainless steel cover, and we're using 1mm thick. This is 304 stainless steel for this one. I'm going to be switching over to the gas saver nozzle. It has a little ceramic tip and that floats on the material. That directs the air to the cut. There are over 860 square holes to make in this grill, so let's see how it does. so it looks like it's piercing the workpiece first, and then it's moving down and cutting each square. This one being a little bit thicker and more complex, it takes a little bit over 18 minutes to finish, and this part looks pretty good. There are some small pieces which did not fall away, but they do come off easily just by rubbing my hand over top of them. So I went back and I looked at the settings, and I had accidentally chosen 2mm thick stainless steel when I made this, so the settings weren't really optimized correctly for this thickness. So that turned out great, and I think it would have been even better if I had used the correct settings. So this is a piece I took off of my 1973 Case 646 tractor. It looked as though it was a piece of ductwork that somebody had formed to fit my tractor for some reason. There are sharp edges everywhere. It's been cut in a whole bunch of places. It just looks awful, and I've been wanting to replace this for 4 years. I bought the sheet years ago. That was the sheet that I cut earlier, but without any great way to cut it, I only got as far as laying out the replacement. So the trick with something like this is getting the angles and the hole positions. So what I'm going to do in this case is I'm going to use the camera on the machine itself to take a flattened shot of the part. And in this case, it's thickness dependent, so we need to put a value in there that's close to the part thickness. And then with that image, I can trace it in xTool Studio. That's going to give me the holes and the angles as well. I can then export from xTool Studio in SVG format, and then I did some refining in Fusion, and then brought it back into xTool Studio for the final cut. Since the sheet is pretty much the exact size that I need, rather than using the machine clamps, I'm going to use these big magnets instead. I'm not sure this is necessary, but I don't want the sheet to move around during the cut. I also decided to add in the Case logo as a cool little detail as well. Now it's just a matter of folding over the edges, and I used the Metal Fab to mark the bend lines as well. What I didn't expect is that this steel is kind of brittle and does not fold very well. And I really do need a press brake for this type of work, but a hammer and a block of wood will do the job. It just takes way longer. Overall, this one turned out awesome. I'm really happy with how this looks. I have a little metal filler piece which can then be added in behind, and it will give this logo a much more subtle and high quality look as well. There's also another camera you can use for very detailed work, and they actually work together as well. So if you're having trouble with capturing any tiny details, you can use this other camera also. So I think we could use that exact same process if you wanted to make a cardboard template. You just lay it on the platform there, use xTool Studio, take an image of that, and then trace it in xTool Studio as well. So those cameras really aren't just for material placement, but they are also for digitizing templates, or at least that's how I'm using them. Now these are shapes for a project that I've been working on, so they don't look like much right now, but they will be turned into a real functional product, and I want to get these onto a sheet without having too much waste. So what we can do is use the camera, we can copy and paste as many times as we want to cut these, and then we can press this button and it will take those parts and move them around and rotate them to get the best use of the material. It's a pretty handy feature, especially for someone who makes knives, for example. I did experiment with a little bit smaller gap, and for my parts, the gap of less than 2.8 millimeters between them did not seem to agree with it for some reason. I'm not sure if that's a failsafe because support becomes a bit of an issue, but I will mention this to xTool to confirm. Again, these are from 1mm stainless steel, and I think this time I used the right settings and they look much better. The nozzle saver ceramic tip does leave these little micro scratches in the surface, but for me, these will be going into a vibratory tumbler to get a uniform finish and also to round over the edges a little bit, so it really doesn't matter. But there are lots of different nozzles and gases to choose from to get the best cut for each material and each thickness that we're using. It's just really a matter of experimenting with that a little bit. Next, I want to make something for all of my vice grips, and I wanted it to have the original logo on it as well. So I took this logo and transformed it into a stencil shape so we don't lose the inside pieces. And I've also added cuts to make bending a lot easier, along with these slots for mounting with screws. I'm using the 1mm stainless steel here again, and that's what I have on hand. And with this design, we're going to keep the grips aligned, and they're going to be nice and tidy as well. So the cutting's going smooth. It does a pierce above again, just like it had done before, and then it moves down for the cut. And you can see that the inside on some of them did not completely fall away, and I'm guessing that's because of the complexity of those parts and also how precise those cuts actually are. There's almost no room for them to fall. I ended up just poking it out with a small hex micro screwdriver, and then I was able to wiggle it through. So I will say this does bend a lot easier, but even with those cuts, it's still pretty tough to bend. Ideally, I would have the proper bending equipment and avoid adding these extra cuts, but for now, it does the job. I have two pieces of artwork that I want to cut. I made this one from a picture that I took of our dog. I was able to convert it into a black and white image, and then I fine-tuned it a little bit as well. I think it did a great job of preserving the impact of the original picture while only using two colors, which is pretty amazing when you think about it. I bought a sheet of 22 gauge galvanized steel for this job, and it will be painted black eventually when the weather improves outside. So this sheet is 4 feet by 2 feet, and the machine has these really nice pass-throughs at each side. There's a skirt there to keep a good seal from light and also from air too. The Metal Fab does have wheels, so I could have just moved it, but that means I need to adjust the leveling feet. So instead, I just decided to kind of bend it and roll it and try and feed it in that way, and I was able to get it. I don't really have much room when it comes to the space in my shop, and in this case the bending seemed to work pretty well. If you had enough space, what you could end up doing is buying an 8-foot piece, or maybe even have material on a coil off to one side and then feed it through. That would help to get a lot better yield. The settings call for me to use the standard 2mm cutting nozzle and 87 psi for this, so I'll swap out the current nozzle for the standard cutting one and we can make some art. I see a lot of generic metal art online, and I wondered whether it was possible to make custom artwork out of metal. And I think the idea of taking someone's picture that means a lot to them and converting it into something like this makes a lot more sense. Total time for this picture was 4 minutes. This one turned out great. There was only 2 little issues that I could have done a bit better on. One is that I probably should have used a bit thicker material, maybe 20 gauge rather than 22. And because of the way the hair was changed over in this image, there are some areas which come to a point and they're a little bit too sharp, so maybe rounding those over a little bit too. So maybe a little bit more refinement before cutting is needed, but again, the cuts look excellent. It was very precise. And it's pretty big, and material cost, because this is so thin, is pretty low. Okay. I also used some of the waste for an idea of hanging this on the wall. I did not like the way the piece bent though, so I ended up pre-bending some of the pieces. And then recutting those parts after the bending process, and they did turn out much better doing it that way. I'm also working on an idea for a single hanger to make mounting even easier. My brother is an artist, and he designed this image of 3 geese in flight. This one is rounded, so there's less of an issue with those pieces coming to a point. So let's make this one. I'm doing this one a little bit smaller because I also want to save enough material for a remake of that piece for my tractor, because I did not like the way that that material bent. This one turned out great. It probably should have been a bit bigger, but I was a little bit short on material. So now I'm going to remake the tractor panel that I made earlier with this material instead, and since it's galvanized, it is better for outdoor use as well. And again, it turned out great. The way I've set this image up though, it isn't a full continuous path because of the score marks that I added in for bending. So it would have been better, instead of having these little score marks, to remove a little bit more material and have a continuous path for cutting. Other than that, it's another successful piece. So the Metal Fab did an excellent job with thin materials, but I also want to know how it does with thicker materials. So I am getting set up to cut thick steel, 1/4 inch or even up to 1/2 inch thick. It will use a different nozzle setup, and it will also use an oxygen tank rather than the compressor. I have the tank already. I'm just waiting on the regulator to arrive and I can start on those tests. Over the past 1.5 months, I've been designing a machine to help with metalworking and with woodworking, and it complements the Metal Fab perfectly. I will be making a full build video on that machine soon, using this laser to cut and also to weld, so we can see the entire process on real parts that I've designed from scratch. So keep an eye out for that video when it drops. It's probably really obvious, but I will say it anyways. Lasers and welders in general are dangerous. So there are goggles for this wavelength of light, but personally I'd recommend the full welding helmet to protect your entire face. Even though the machine has a protective cover on it, I'd also suggest that it's better not to watch the machine running, just to be safe. There is no live view camera on the Metal Fab. That is something I would like to see, though I do understand it's not quite the same environment inside as you'd see in, let's say, a 3D printer, so it's probably not as easy as just putting a camera in. I also noticed that the sand in the bottom is interacting with either the laser or maybe the air that's passing through there as well, and it's getting distributed around the bottom of the cabinet. Maybe adding water is a better option after all. I was thinking to ask xTool if rock wool insulation might also work. It would be a great soft landing for parts, and it could absorb the laser without blowing around. Overall, this is a very capable and well-engineered machine, and I think it can save a lot of time and money for anyone who does metalworking, and it can also make the job a lot faster for cutting your parts, and even allow you to design and make parts that are far more complex and have much more precise cuts than if they were cut by the CNC or cut by hand. It cuts up to 1/2 inch thick, but I think it's probably better suited to a little bit thinner. It can give you clean cuts on a 1/4 inch or even 3/8 of an inch thick steel. We will test that in an upcoming video in the next weeks on real parts. It has some really well thought out safety features, the cabinet being the obvious one, but it has collision avoidance as well. It will hop over areas that are prone to twisting and parts raising up. And if it does hit that part, it will detect it and then wait for you to remove that obstacle, like what happened here. Now when you do, you just press the button and it's going to continue after that. There are safety warnings which come up each time on the machine when it's powered on as a reminder, so you know what to be aware of, which I think is really smart. The software also allows any image to be converted into an SVG to be able to work with it in programs like Fusion. This is not a cheap product. This is a product that's meant to be used day in and day out 24/7. So it does come with a price. At the time of making this video, for the 1200 watt laser welder, it is $7,999 US. The combo with the laser and the CNC cabinet is $15,999 US. There is a kit option coming for a less expensive version too, using the 800 watt laser as well. And because this whole setup is modular, it's a good option to start with, and then upgrading down the road to maybe the 1200 watt if it's needed for thicker materials. I'll leave links below to check on the prices if you're in the market for a machine like this. You can also use discount code NM100 for $100 off of any 1200 watt Metal Fab. or 1200 watt Metal Fab bundle. I'd like to thank xTool for sending the Metal Fab to me to test out, and I'm looking forward to using this machine next on industrial thickness parts so we can see how the cuts look on those thick materials, and of course we will be welding on those thick parts as well using the 1200 watt laser. If you have any questions about the welder or the CNC cutter or both, let me know and I'll get back to you as soon as I can. And thank you to each of my patrons for helping to support this channel. Take care, and I hope to see you on the next one.